Hi, so this is the fifth video in the Math 83 factoring section. We're going to look at special factorizations in this video. You don't have to have watched the other factoring videos to be able to get this, but I highly recommend it because it is just part of factoring. So the type of special factorization we're going to look at is called difference of squares. All right, and so whenever we're looking at a difference of squares, we're looking at something that has this format. Something squared minus another something squared. Now it's really important that it has this format. You have to have something squared minus, so a plus does not work, something squared. Now you can treat this like a normal factorization if you want to. You can take it apart either by trial and error, or you can take it apart using the AC method that we looked at in previous videos. But we have a special factorization rule for this one that allows you to factor very quickly and you don't have to do a lot of work. So the rule is, if you have something squared minus something squared, what you're doing is you're looking at what is being squared here. So you're going to have something called A that's being squared and something called B that's being squared. And your factors are going to look like the sum of those things times the difference of those things. All right, so if you can identify what's being squared, factoring it is really quick. All right, let's do some examples. Okay, so let's look at x squared minus 81. So first let's convince ourselves that this is actually a difference of squares. So x squared is kind of obvious. X is being squared. We have a minus, that is great news, and 81 is 9 squared. So now we've identified the two things that are being squared, and there's a difference. So this is a difference of squares. So we know what our factors are going to look like right away. We're going to take the things being squared. The first factor will, or one factor, doesn't have to be the first one. One factor will be their sum. The other factor will be their difference. Now the reason this does end up looking like this whenever you multiply it back out, it looks like our trinomial factors like we did in the last video. But whenever you go to multiply these out, you definitely get the x squared here, and you definitely get the minus 81 here. What ends up happening with the outers and the inners is that we end up with minus 9x plus 9x, which is just 0, so we don't end up seeing it. So don't be alarmed. The factors are going to look like they did before in previous examples, but we have an x squared minus 81 as what we're factoring, because those outers and inners just end up being 0. All right, let's look at another one. Okay, this next one we're going to look at is 4x squared minus 25. All right, so first of all, this is a difference, and it's kind of got that form of difference of squares. We've got just two terms, and they're being subtracted. All right, so now let's look at what happens if we try to figure out what's being squared here. So 4x squared, using our rules of exponents, we know that 4 is 2 squared, and x squared is just x being squared. So if we square the expression 2x, we get 4x squared. So 4x squared is 2x being squared. And 25 is 5 squared. And there is a difference between them. So now that we know the things that are being squared here, we know what our factors are going to look like. One factor will be the sum of the things being squared. The other factor will be the difference of the things being squared. And if you multiply this back out, if you FOIL it back out, you should end up exactly where you started. All right, let's just look at a couple more to make sure we cover all our bases. All right, and then this next one, we have 32x squared minus 18. Okay, so certainly these are two terms, and there's a difference between them. So let's try to figure out if we can see what's being squared in these terms. Well, we certainly have an x squared here. That part's easy. What about the 32, though? 32 is not a perfect square, meaning we cannot write it as a number squared. Neither is 18. So now we have to go back to the very first factoring video. Our very first try whenever we're factoring is to try to take out a greatest common factor. So if you notice that this looks like a difference of squares, but it can't be written as a difference of squares right away, try to take out a greatest common factor. And if we look at 32 and 18, I think our greatest common factor here is just 2. So let's take out a 2. What's left if we take a 2 factor out of 32, we're left with a 16, and we have our x squared. And if we take a 2 factor out of 18, we have 9. Okay, so this is looking better already. We have this 2 out here, which just has to hang out for a few minutes. And 16 now is a perfect square, so we can write that as something squared, and so is 9. So let's go ahead and write that as something squared. So 16 is the same as 4 squared, and x squared is the same as just x being squared. So we can rewrite 16x squared as 4x being squared, and we can write 9 as 3 being squared. And now we have a difference of 2 squares, and we know how to factor that. So this 2 just kind of stays, because we factored it out at the beginning, and we know what our factors look like. The sum of what's being squared and the difference of what's being squared. And again, if you were to go ahead and multiply all this back out, and then you'd have to multiply the 2 through at the end, you should end up exactly where you started. And we would only get 2 terms, even though this looks pretty complicated, because keep in mind, this is going to be negative 12x, and this is going to be positive 12x. They're going to end up canceling out. All right, one more of these so that you know what to do and you're not banging your head against a wall trying to do something you're not allowed to do. So let's look at x squared plus 4. Okay, so we can definitely tell that this is a combination of things being squared. This is definitely x squared. It always has been. And 4 is definitely 2 squared. All right, so we might go straight to x plus 2 times x minus 2, because that's kind of what our form looks like. But if you multiply that back out, you don't end up here. You end up with x squared minus 4. So you might try several things to try and factor it, but you're never going to end up back here. The reason is this is not a difference of squares. This is a sum of squares. And like we said at the beginning, we don't have a rule for a sum of squares. We just have a rule. If this had been a subtraction, we could have factored it pretty easily. But this isn't a subtraction. So if you ever see this happening, stop. And the answer is that it does not factor. So a sum of squares in general does not factor. A difference of squares does. And that's it for the factoring section.